Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izrat bin Ahmad Saiful and I'm responsible for this project. The title of this project is Kenaf Fiber Reinforced Recycled PVC, a sustainable PVC composite.
Okay, my name is Dr. Mariati Jaafar. I am the supervisor of this project.
As you know, plastic waste is a growing crisis. Malaysia, for instance, ranks 8th globally in contributing to this problem. Despite all our efforts, only 9% of plastic waste was recycled globally in 2019, and even with projected increases, this number will only reach 17% by 2060. Meanwhile, the rest ends up in our oceans, landfills, or worse. Every year, floods devastate schools and institutions in Malaysia, leaving 90% of submerged wooden furniture damaged beyond repair. By replacing this with furniture made from recycled PVC composite, we're not just solving one problem, we're solving two. Number one, we're reducing plastic waste, and number two, we're creating flood-resistant furniture that lasts. We're proposing to create sustainable, durable furniture using recycled PVC combined with Kenaf fiber. Why PVC? Because it's strong, UV-resistant, fire-retardant, and has a low water absorption rate. These qualities make it an ideal material, especially in regions like ours where floods are a recurring issue. Malaysia has a significant amount of Kenaf plantation, as well as Kenaf is a fast-growing plant with exceptional fiber quality, making it an ideal candidate for reinforcing recycled plastics. In our study, Kenaf fibers were tested according to the Association of the Pulp and Paper Industry (CAPE) standards and were found to contain over 70% cellulose, which it directly contributes to the strength and durability of the final composite material. We all know that recycled plastic, while environmentally friendly, often falls short in strength and durability due to the repeated heating and processing it undergoes. That's where fiber reinforcement comes in. Over the years, natural fibers like wheat husk, rice straw, and wood are used to enhance the mechanical properties, but today, I want to focus on a fiber that holds immense potential yet has been relatively overlooked, which is Kenaf. For our project, we have selected rigid PVC. This choice is crucial because rigid PVC provides a solid, durable base that's essential for our furniture applications. Let's start with the basics. Our process begins with collecting PVC waste, which is then cleaned and crushed into small pieces. But recycled plastic, on its own, often lacks the mechanical strength needed. That's where our research comes in. We're focused on finding the best formulation to reinforce recycled PVC with Kenaf. Various parameters such as Kenaf loading 5%, 10%, 15% and 20% have been considered, while formulation properties were used for furniture applications. To achieve this, we're using a twin screw extruder. This method ensures that the recycled PVC and Kenaf fibers are effectively blended, resulting in a uniform distribution of the reinforcing material within the polymer matrix. The process begins by inserting all the mixture of the formulation into the loader, where the screw mechanism gradually pushes the mixture towards the first chamber of the twin screw extruder. As the material moves forward, it undergoes a controlled heating process, with the temperature steadily increasing as it advances through each subsequent chamber. This precise temperature control ensures proper melting and mixing of the composite materials until the mixture reaches the final chamber, where it is then extruded through the die, shaping the material into the desired form. We don't stop at just creating the material. Our composite samples are molded according to STM guidelines and rigorously tested for tensile and flexural strength and fire resistance. We began by accurately weighing the crushed samples to ensure proper proportions for testing. First, we sprayed mold release onto the mold surfaces to ensure easy separation of the samples after processing. Next, the weighed samples were evenly spread onto a specific ASTM mold. The mold was then placed onto the heating element of the hot press, where it was compressed under high temperature to facilitate melting and proper flow of the material. After sufficient heating, we held the sample under pressure for a few minutes to ensure good bonding between the particles. Finally, the sample was cooled by transferring it back onto the cold plate, where it was repressed to solidify the material and complete the molding process.
After the cooling process, the sample is carefully removed from the mold and trimmed to meet the exact dimensions specified by STM standards for the flexural and flammability tests. For the tensile test, the process is repeated using a specific mold designed to produce tensile test samples. This ensures that the samples are properly shaped and sized according to ASTM requirements, allowing accurate and consistent testing across different mechanical properties. To produce the prototype for the furniture, we utilized a 3D printer to create a scaled-down version of the design. In this case, we specifically printed a miniature model of a chair, which allowed us to visualize and evaluate the structural features, proportions, and overall aesthetics before moving on to full-scale production. This method provided a cost-effective and efficient way to refine the design and ensure that it met our expectations for both functionality and form. Now, let's talk performance. We've compared the tensile and flexural strength of our reinforced composite coated as PVC RX20 cave to other variations controlled and also with additives alone. The results are promising. Our reinforced composite meets and even exceeds the strength requirements for furniture, which typically ranges between 10 and 20 MPa. Additionally, all the samples demonstrated excellent extinguishing properties as they self-extinguished within a few seconds. Since we use rigid PVC combined with Kenaf fiber to create a strong, durable composite that meets the requirements for furniture, our twin screw extruder and 3D printing technologies ensure precise, scalable production. By using recycled PVC and natural Kenaf fiber, we're reducing plastic waste and minimizing our reliance on new materials. This approach supports sustainability and a circular economy.